Thank you for introduction. This is my great honor to give my research talk as a presidential lecturer here in KSSCR. Today I'm going to tell you the ongoing and also past experiments in our lab, the substance P, which is a small 11 amino acid neurotransmitters, which acting as a stimulant of endogenous healing mechanism, recalling the stem cell, endogenous stem cell in the bone marrow. So I would like to start off with this lecture slide. So if you see here from the fertilized egg, you will see diverse the stem cells. When the embryonic development proceed, the diversity of the stem cell potential for the differentiation decrease. But at the newborn baby, you will see many adult or tissue stem cells are stored in the stem cell tissue environment here. And those tissue stem cells will continuously provide 200 at least different shading functional cells in our body. So if you're looking at in our body, so from those baby to up to adult, and even in our lifetime, those adult tissue stem cells will provide these cells. So you could find out many stem cells as a reservoir, as a bank for the stem cell in the bone marrow, and also in the brain, and also crypt and hair follicles. So all sorts of tissue seems to have its own, or maybe unipotent or multipotent stem cell in our body. So this is kind of rough calculations. If you are 60 kilograms of adult, so you may have these numbers of the cells in your body. But based on cell biology textbooks, so about 1/200 of the cells are dying every day. So you might expect that the stem cell may have really long-lasting powers to replenish all those differentiating cells in our body. So with that, a lot of people use to the bone marrow aspirate or other tissue source to expand those stem cell, other stem cell in vitro, and let them put it back to our body as ex vivo culture cells. So those clinical results tells us that many of those cells play a role as a paracrine immune modulating factors, but it is very expensive. You have to pay about $10K or $30K for each injection. And also it has really lower engrammment and homing. And also you are injecting as a bolus to the blood. So you might expect heavy traffic of those stem cells in your body. But if you're looking at the other side of the stem cell, which is the stored endogenous stem cells in our body, so if we prove certain molecules which could stimulate self-renew and mobilizing and homing to the injured tissue. So if we use those kinds of trafficking and self-renewing property, we could ask those endogenous stem cells directly engage in situ tissue repair in our body. So if you found out those molecules and prove the efficacy, it may be used immediately at the emergency rooms like cardiovascular disease and stroke. And also it may have more chance to grow better in the global markets. So if you see the nature's paradigms for tissue regeneration in case of lower animals, you will see when the limb was stamped, the newt could regenerate its own limb within 20 days. So lower animals seems to have powerful endogenous healing mechanisms. But how about the higher animals or mammals? So our hypothesis was if you have a tissue injury, it may create in the specific microenvironment. This may give the signal in our body as alarming signal to stimulate stem cell mobilization from the bone marrow. So from our hypothesis, from the tissue injury, it may create in the specific microenvironment enriched in those inflammatory cytokines and growth factors. And also from those tissue damages, from probably sensory neuronal damages, you might expect a severe pain and also neurohormonal response abundant in those neurotransmitters. So any molecules which has a high enough concentration and long enough half-life, it may have chance to migrate to diffuse to the peripheral blood and reach to the bone marrow, which is highly perfused organ. And it may activate the stem cell there and mobilize and let them engage in tissue repair. probably the injury itself could create tissue hypoxia. It may be kind of signals for homing those cells. So in case of EPC, this kind of system was known before for the myocardial infarction. So if this system is working from tissue injury, it may create one of the endogenous healing mechanisms yet to be identified. So in this Nature Medicine paper 2009, we identified the substance P, which is made as a polyprotein from the PPT1 gene and cleaved in 11 amino acid neurotransmitters. These are really conserved in mouse and rat and human being. The sequence are the same. And the receptor for this neurotransmitter, which is known as pain-sensing neurotransmitters in CNS, is found in non-neuronal cells, like bone marrow stromal cells are expressing these receptors and delivering signals through GPCL. And we would like to add another novel functions of this one as injury-induced messengers to mobilize bone marrow stromal cell. So most of this work was done by the graduate student Han-Suk Kong. Now she became a professor at the Kyungju University. So there we found the substance P has a novel function working as injury-inducible alarming messengers to mobilize bone marrow stromal cell from the bone marrow to the peripheral blood and let them engage in tissue repair. So the first data that we have is when we're looking at the eye and the RT-PCR, we are able to see all those candidate molecules increase. Among them, the substance P also increased really fast. And immunohistochemistry, we are able to see substance P peptide here, and it disappeared at a later time point. At the same time, we are able to see increment of the substance P in the blood. And also, on the healing phase, we were able to see big alpha-synuclein positive fibroblastic cells. So we are expecting are they those bone marrow stromal cells coming from the blood. So in order to test those kind of scenarios, we injected substance P peptide without injury, and then we collected the blood to see whether these kind of candidate bone marrow stromal cell is appeared in the blood. So when we injected substance P, it increased these candidate cells in the blood, and when we co-injected the receptor blockers, it blocked. And at the same time, we were able to see CFUF increase in the bone marrow after the substance P injection. And then we asked whether the intravenously injected biotin can able to reach to the bone marrow stromal cell in the bone marrow. So we injected substance P biotin conjugated one, and when we take the bone marrow aspirate out, so we were able to see those cells was found was the CD29, CD105, and 106 positive. So based on the markers, so this is probably the candidate for bone marrow stromal cell. Then we we try to answer the question whether these are injury-induced messengers truly mobilize bone marrow stromal cell. If it does, probably these two kinetics may be affected by the injury site. So we changed to the rabbit system, which has a big eye, so we could make either two bone on the same eye or one bone on the eye. So in case of a two bone, we were able to see the peak levels of substance P induction instantly within an hour comparing to small ones. And when you take the blood out and when we cultured without bone, we were not able to see fibroblastic cells. But in the bone at day 5, we were able to see CD29 positive candidate of bone marrow stromal cell and CD45 positive monocyte, those are adherent cell you could see in the peripheral blood. And also bone marrow stromal cell mobilization was faster in two bone, and the kinetics was faster, and the amount was much higher. So from that, those are probably injury-inducible alarming molecules to mobilize bone marrow stromal cell. And then, in order to firmly prove that whether these are really bone marrow stromal cell, so we take the peripheral blood after substance P injection, and then we remove all the CD45 positive cells. And from those CD25 positive cells, in the FACS analysis, they were all 90% over in the bone marrow stromal cell markers, and they were able to differentiate it to chondrocyte and adipocyte and also the osteoblast. And when we take those cells from the peripheral blood, and then when we mix together with the hydroxyapatite and tricalcium phosphate, and then we transplanted on the back of the noodle mouse, see whether they could make ectopically bone and bone marrow on the back of the noodle mouse. Those are the bona fide markers to prove those are the bone marrow stromal cell, not the adipose stem cell and other mesenchymal origin. So we were able to get rabbit lamella bones here. And within those lamella bones, we were able to see the hematopoietic zone. Those hematopoiesis came from those the mouse origins. Okay, so when we were able to see that those bone marrow stromal cell was mobilized by substance P. So in order to test the efficacy of the substance C, whether it's accelerating on the healing, so we make one bond and then we injected these two, and we also injected different concentration of substance P. So when you injected different concentration of substance P in a dose-dependent manners, the bone marrow stromal cell mobilization gets forwarded shift and the magnitude was increased. And also wound healing was much higher, and those difference was able to seen at day 3. So day 3 is the time, initial time for bone marrow stromal cells mobilized to the blood. So we could expect those mobilized cells probably engage in tissue repair. So in order to test that, we take those cells out to the same rabbit. We made the autologous cell transplantation the tools. And so we take the cells from the same rabbit and labeled these PKH26, and then when we injected to the rabbit at 3 days and post-injury, we were able to see accelerated wound healing similar to the substance P, and those was found in stroma and also the corneal layers. When we injected at different time points, all of them would stay there in the epithelial cell and also stromal cell, and those were negative in alpha smooth muscle actin bone marrow stromal cell markers, but they express in K3, the corneal keratin markers. So they seem to be engrafted in the stroma as well as epithelial layers. And substance P also increased cell population by the PLDU incorporation in a dose-dependent manners and ERK activation, and also substance P stimulate the translocation of beta-catenin in a dose-dependent manners to the nucleus. So we think the substance P initially increased the population size of the bone marrow stromal cell in the bone marrow. Those probably may stimulate the migrate out. In order to looking at the migration, we did in vitro 3D cell migration assay. So in a dose-dependent manners, substance P stimulate the mobilization, and also those seems to be chemotactic. The gradient is required for that, and also for the mechanism, we were able to see the MMP induction was increased and TIMP induction was decreased, and also in the cell lysis, we were able to see MMP, MT1, MMP2 was associated with TIMP and MMP2. So local degradation of collagen may be required for those kind of chemotactic migration. So from that, we concluded that if you have injury, substance P diffuse to the blood and reach to the bone marrow and mobilize those bone marrow stromal cells to the blood and let them engage in tissue repair. If this kind of system is not working, maybe substance P as medication could be supplied to accelerate this kind of endogenous healing mechanisms. So from those experiments we were done in the corneal wound healing, but if you have a tissue repair, maybe vascular genesis may be more required. So in order to have a tight and healthy blood vessels, if you see in the retina and also BBB, pericyte and endothelial cells are always present in this kind of lesion. So the pericytes cover those endothelial as a ceiling, encircling the endothelial, so they could control the contractility and also tightness of the vessel. We are expected whether those bone marrow stromal engage as a pericyte in these conditions. So if it does, the bone marrow stromal cell, which could be transferred to the pericyte, it may create tight, healthy blood vessel. But only the endothelial cell, maybe you might expect leaky pathological vessels. In order to compare those, we tried to compare these two drugs. So G-CSF was initially developed for the neutropenia, so we could expect maybe under injury condition it may cause more inflammation. And it is known to mobilize EPC from the bone marrow, but a lot of people claim that it's not mobilized bone marrow somal cell. So we try to look at whether substance P could these kind of functions. So first thing we have done, we injected substance P intrafemoral, intra-bone marrow, and then see whether the CFU-E and CFU-F are changed under those conditions. So one side was injected substance P, the other was saline. So we compared the same pattern, the patterns of CFU-F in the same rabbit. So the EPC, which is denoted here, the CFU-E, was increased in the bone marrow aspirate in 1 day after substance P injection to the bone marrow, and it decayed as time goes by. At the same time, we were able to see EPCs appeared in the peripheral blood, and those kind of EPC kinetics was blocked by NK1 receptor. And also bone marrow somal cell, which is denoted here, the CFU-F cells, those are also increased in the bone marrow aspirate by substance P, and when it goes by, it increases in peripheral blood. Those two was inhibited by NK1 receptor blockers. So those are specifically working as a substance P receptor, and substance P actually mobilize bone marrow somal cell as well as endothelial precursor cells from the bone marrow. And when it injected the biotin-labeled substance P, it binds to bone marrow stem cell and EPC candidate in the injected site, and within a day we were able to see proliferating cell population. So we think the substance P injected to the bone marrow bind to this NK1 receptor positive EPC and bone marrow somal cell and proliferating, and those probably may be the source for this migration. Then when injected substance P intravenously, this may be more kind of injection route for the clinically. So even when we injected intravenously, EPC was induced, mobilized, and also bone marrow somal cell was mobilized. Both two was inhibited by the NK1 receptor blockers. Then we take the NK1 positive cells from the peripheral blood and see whether those are real EPC, has a EPC characteristics. So when we culture those were BE cadmium positive and CD1 133 positive, and in the culture it was positive in CD34 and 31, and the NK1 receptor, which is cultured in MSC GM cultures, those show the bone marrow somal cell characteristics. When we did Metriger assay, EPC make a blunt, the endothelial tube-like structures, bone marrow somal cell did not, but when mixed together, they make really nice vascular network. So we think maybe these two cells may work as concerted in vascular genesis. So we did the Metriger prog assay, and those green-colored endothelial tube was decorated by the red colors bone marrow somal cell in the Metriger assay, and also full thickness in the when it transplanted, it could make. In case of EPC, it could make really balloon-like structures which is deficient in alpha-smooth muscle-actin positive pericyte, but in this case, it's small, but it was all covered by the alpha-smooth muscle-actin positive. So we think maybe when these two cells are present, maybe working as a concerted in the tissue repair. So we tested those in the alkali bone wound, so we were able to see the substance P could stimulate. We were able to see the EPC and bone marrow somal cell was also induced, mobilized under this injury condition, and it was blocked by the receptor blockers. And also when we injected substance P, we were able to see in the regenerated tissue, we were able to see all those vessels was covered by alpha-smooth muscle-actin, the candidate pericyte in this case. And also immunohistochemistry, we were able to see all the vessel was covered by alpha-smooth muscle-actin positive. But at the same time, when we transfuse EPC only, so we were able to see the vessel, but it's more like a balloon-like vessels which are deficient in pericyte. And when we are looking at the co-injection of those, we were able to see vessel was all covered, endothelial cell was covered by pericyte-like structures. So the substance P could mobilize not only bone marrow stromal cell and the ciliary precursor cells from the bone marrow to the blood. If substance P has this kind of function, you might expect more efficient the disease models like stroke or myocardial infarction, see whether it's working. So if summarized, substance P could mobilize these two cells. I didn't talk about this one, but I will talk about this one later. The GCSF mobilizes only EPC. It has a pro-inflammatory loss. I will show you this one later. So substance P can mobilize those to dual cell migration, but the GCSF mobilizes only EPC. So this may be more advantage in the tissue repair, especially tight vascular regeneration. So in order to test those one, I co-worked with the cardiologist Wan Kim at Gyeonghae Hospital. And what we have done is we made the LAD ligation and IR model. And we look at whether under those disease model, those bone marrow EPC and bone marrow stromal cell are mobilizing. The substance P successfully mobilizing EPC and also bone marrow stromal cell, but GCSF could mobilize EPC but quite deficient in the CFF mobilization. In terms of inflammation, injury itself could increase the neutrophil surge. This is the typical injury-mediated inflammation. This one was suppressed by substance P. And when you injected together GCSF, you extended those inflammatory period. We were able to see same kind of patterns in TNF-alpha. Injury-mediated TNF-alpha increase was suppressed by substance P, extended by GCSF. So it's quite clear that GCSF seems to increase the inflammatory burden under injury conditions. And when we're looking at the cardiac tissue, and TTC staining, the substance P decreased the infarct zones and decreased the fibrotic zones, and also all those vascular was covered by alpha-smooth muscle-actin positive pericyte 1. And also when you're looking at the echocardiographs, so we were able to see increased cardiac contractility. So if you see here in fractional shortening and ejection force, this is the sham control and PBS. Comparing to PBS, it increased contractility, and it is better than the GCSF injected one. When we did the permanent ligation, we have a similar kind of result. So from that, we decided to develop this substance as a stem cell stimulant to repair a variety of tissues. And we made a conjugated form of palmitic acid. In this case, we increased the lipid solubility. So this could be used like atopic dermatitis, and also co-work with the Sungwoo Jo at Yonsei University. We made a pegylated substance P. This one increased the stability, half-life in the serum, so we could compare these two in this chemical limb model. So if you see here, the substance P increased limb cell base comparing to this one, and PEG-SUB was quite similar or better result for that. Then within a couple of minutes, I would like to introduce substance P's another function which is working earlier than bone marrow stromal cell mobilization. So substance P seems to have induced anti-inflammatory loss in the variety of CNS the tissue damage. So we were able to see substance P reduce apoptotic cell in spinal cord injury, and we were able to see those in the spinal cord injury region site more M2 types of macrophage are abundant there. For that, so in the in vitro experiment, we recently proved that the substance P, which is a neuropeptide, but it directly induces tissue repairing M2 types of macrophage. The mechanism of action is activating PI3 kinase and AKT and mTOR pathway, which is working even in the presence of pro-inflammatory Th1 cytokine. So we expect this substance P may work in the inflammatory environment, suppressing those inflammatory cytokines action, leading to the tissue repairing M2 types of macrophage. So if I summarize, the substance P initially actually stimulate the migration of the bone marrow monocyte to the blood, which happens within 4 hours substance P injection. And this substance P also stimulate and induce those monocytes into arginase 1 positive, CD163 and CD206 positive M2 types of monocyte, the skewed one, and then let them infiltrate to the injured site, and there they seem to have a positive loss in tissue repair. So we have done those adaptive therapies. Those cells could reach to the lesion site and seems to increase the tissue repair. And if I show just some couple data, so because M1, M2 transitions, arginine usage may be very important. And M1, they may use arginine as iNOS to production and NO, and in this case, arginase for the cell proliferation. So if you see here, the interferon gamma is Th1 cytokines. Arginase activity was increased even in the presence of interferon gamma, and also NO production was at the same time is blocked by that. So we think the substance P is one of the noble cytokine which could work either bone marrow monocyte or activated macrophages, so it could induce to the M2 types of macrophage. This substance P probably working on the high inflammatory conditions could from M1 to transfer to the M2 types of macrophage. So when we have a tissue injury, so we cannot, the inflammatory response are inevitable. But the substance P could maybe reduce the secondary tissue damage from the injury-mediated inflammation and let them move to the anti-inflammatory environment, so reduce cell apoptosis and clean up those dead cells, make ready for those reparative stem cells coming from the bone marrow to the injury site, let them engage in tissue repair. So with that, so we are actually developing this one as a stem cell stimulant. Right now, we are at the stage of ready to get into the IND. So I didn't have time to show you all those efficacy preclinical data, but we tried all those disease models. So substance P seems to be quite effective. So this is the stage that we are looking for how those phase 1 could be turned out for that. So this is the end of my talk. This picture was taken about 4 years ago, so we have a huge members here. But now the Professor Bach, she has her own lab here. So some of my graduate students moved to the Kyung University, the medical school, and she has her own lab. And Hansu Kong, she also has her own lab. These seems to be quite old members, but they have independent labs. And my work was supported by numerous grants from those Korean Ministry of Science and ICT Technology, and this big project was supported for this kind of work. And also the clinical study work was supported by the Ministry of Health and Welfare. Thank you very much.